What's up, guys? Welcome to Unit 3. This will be your introduction to proofs, which I'm sure you all will love very much. So this is our reasoning um, for steps in proving that things are true. So I'm going to do a couple examples so you guys can get the hang of it. First off, we'll start with just some key vocab, some key things that will be used for your reasons. You have the addition property, that's when you add to both sides. Subtraction property, subtract from both sides. Multiplication and division property, same thing. You have the reflexive property, which is when you have something that is equal to itself. So A equals A. You have the symmetric property, where something is equal, then you could just flip it around so that it's equal if you write it the other way. So here we have A equals B, and you can also write that as B equals A. So that's the symmetric property. The transitive property is next. That says if A is equal to B and B is equal to C, so A is equal to B and B is equal to C, then A is equal to C. So A is equal to B, B equal to C, then A is equal to C. Next, we have the substitution property, which is when, like in sports, you put something in place of something else. So you substitute it in. That'll make more sense when we do an actual example. And last but not least, we have the distributive property, which you all learned how to do many years ago. That's when you multiply the term on the outside by all the terms on the inside. So those are kind of some of the properties we're going to be using. When we get to the second page of the notes, there'll be 3 or 4 more properties that you guys will use as well. So let's just start with these for now. So for our first example, I told you guys this couple of class periods ago, it was on your first exit ticket, that the first statement that we write is always going to be the one that they give to you. So given 2r minus 7 equals 9. Okay. That's given to us. So the first statement, the first reason is always going to be given. Now we're going to solve this just like any algebra problem. And then for the steps, those are going to be our reasons. So first thing we would do here is add 7 to both sides. Okay. And that would give us 2r equals 16. So step 2 is actually going to be that part, the 2r plus 16. I just wanted to show you the step in between. And we did that by adding 7 to both sides, so that's going to be the addition property of equality. And then from here, we would divide both sides by 2. So 16 divided by 2 is going to be 8. So r equals 8 is actually going to be our last thing that we proved by using the division property, since we divided both sides by 2. So there wasn't enough space for me to write the steps in between. So I showed you and then I went back and erased, but we did plus 7 here, plus 7 here, divided by 2, divided by 2. So that's how we got to r equals 8. Next we have an equation, and by the look of it, we have a number outside of parentheses. We're going to be using the distributive property. So again, the first step is always given. We have 55z minus 3 times 9 plus 9z plus 12. I need to calibrate the smartboard. Hold on 1 second, guys. Oops. Okay, I'm back. So our given statement is the original equation, 55z minus 3 times the quantity 9z plus 12 equals negative 64. Okay. Well, I showed you already, but you have a number outside of parentheses, so you're going to have to distribute. That's going to be 55z minus 27z minus 36, and that's going to be equal to negative 64. Okay. We got to that statement by doing the distributive property, so that's going to be our reason for this one, for this step. Now we're going to go ahead and solve like normal. So we have 55z minus 27z. That is going to be 28z minus 36 equals negative 64. Now, when you're doing an operation on only one side of the equal sign, that's combining like terms, we're going to say either combine or simplify. So we did 55z minus 27z, we got 28z, so that's just simplifying it down. Next, we would add 36 to both sides, and we would get 28z equals negative 28. And since we added to both sides, that is going to be the addition property. Okay. And finally, we would divide both sides by 28. And we would get z equals negative 1. And we got that by doing the division property. So that is all for that proof. Now we're going to move on to something a bit more complex. We're going to talk about some actual geometry proofs. So if we go to the next, if you turn your page, we have 3 more key concepts. Reflexive property. That's just saying an object is equal to an object, so or congruent to an object. So AB is congruent to itself, or angle A is congruent to itself. Symmetric property. If AB is congruent to CD, then CD is congruent to AB, so you can write it the same forward and backwards. And then transitive property. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. So I'm going to use colors here to kind of illustrate the point. Red is equal to green, green is equal to blue, then red is equal to blue. So for our first proof, so these are going to be called 2-column proofs, because our first column is statements and our second column is reasons. So that's why we call it a 2-column proof. Here we have given the measure of angle 1 equals the measure of angle 3. Okay, so that's given to us. Second step, we have the measure of angle 2 is equal to the measure of angle 2. Now, anytime something is equal to itself, that's going to be the reflexive property. For step 3, we got Measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus the measure of angle 2. So we added the measure of angle 2 to both sides. So that's going to be the addition property of equality, or addition property for short. Now we're going to look at the measure of the angles that they give us and actually plug in the names of the angles. So angle 1 is ABE, or AEB, excuse me. So angle AEB plus the measure of angle 2. Well, angle 2 is BEC. So angle BEC is congruent to the measure of angle 3. Angle 3 is CED. And then we have the measure of angle 2 again, which is just BEC. And so in this step, we plugged in the names of the angles for the actual measures of the angle. So anytime we plug something in for something else, that is called substitution. So this is the substitution property. Okay. Now the last step is always going to be what you want to prove. So if you want, you can always fill this in at the beginning. So the proof statement is always what you want to get to at the end. So we have the measure of angle AEC is equal to the measure of angle DEB. So how do we prove that? So given what we have. Well, we have AEB plus BEC. So red plus green. AEB plus BEC. Well, if you look closely, AEB plus BEC is the same thing as AEC. So we added those two angles together to get the bigger angle. And the same thing with CED plus BEC. If you add those two together, it would actually give you angle DEB. So we're adding two smaller pieces together to get a bigger angle. That's going to be the angle addition postulate. So we can just write angle addition. Okay, so that is it for this proof. We're going to move on to the next one. This will be the last example, and then I'll let you do the last two on your own. And I'm gonna write a word bank on the video so you guys can have that to use. So for 18, C is the midpoint of AD. First step is always given. AC is congruent to CD. So this part and this part are equal. Well, how do we know that? Well, if C is the midpoint, so C is in the middle, that would have to mean that the other parts are equal to each other because they're split in half. So AC is congruent to CD, well, because that's the definition of a midpoint. So definition of midpoint. So based on that, we know that AC is equal to CD. So the parts are congruent. So the measures have to be equal. And then instead of AC for step 4, we have 4x instead of AC. And then instead of CD, we have 2x plus 12. So we plugged in 4x for AC, and we plugged in 2x plus 12 for CD. So anytime we're plugging something in, that is the substitution property. Now here we have a reason. We have subtraction property of equality, so that means we're subtracting something from both sides. The only thing we could move, or not the only thing we can move, but the thing that would be easiest to move is the 2x. So minus 2x from both sides. We would get 2x equals 12. That's the subtraction property of equality. And then the last thing we would have to do to get x by itself is divide by 2 on both sides. And that would give us x equals 6. And that is going to be the division property of equality, because we divided on both sides. So that is it for the examples. I'm going to give you a word bank for the reasons on 19 and 20, because I want you guys to do these on your own, but I think it might be beneficial for you to have a word bank. So these are not in order, but the reasons that you're supposed to use for number 19, substitution is going to be one. Division property of equality is going to be one. Given, of course, is going to be one. We're going to have angle addition. So 2 angles adding together. It's going to be one. Simplify. Is going to be one. And then finally, subtraction property. So subtraction property. So these are going to be the 6 reasons for number 19. And then for number 20, I'll give you the 3 reasons. Again, not in order, but we have substitution is going to be a reason. Subtraction property of equality is going to be a reason. And finally, the transitive property. You're going to need to use that. Now in this proof, we actually have an extra step. You don't need this one. And then for every proof, the last statement, the last statement is going to be what you're trying to prove. So for number 20, we're trying to prove that x equals 5, so that's going to be your last statement. And for number 19, we're trying to prove that x equals 8, so that should be your last statement. So that should go statement F. Alright, you guys try these on your own, and when you're done, let me check it, and then I will give you the next thing that you need to work on. But this is it for your introduction to proofs.